Bismillahirrahmanirrahim. In this lecture, I am solving problem 6.5. So, the statement of the problem is problem 6.5 from the book Applied Thermodynamics by McConkey. The statement of the problem is the mixture of problem 6.4. Means that in this problem, a reference of problem 6.4 is given. Is to be changed so that it is 70% CO2 and 30% N2 by volume. And problem 6.4, there is equal volume of nitrogen and carbon dioxide. Equal volume of nitrogen and carbon dioxide mean 50% of nitrogen and 50% of carbon dioxide. But in problem 6.5, carbon dioxide is 70% instead of 50%, and nitrogen is 30% instead of 30%. So calculate the mass of mixture to be removed and the mass of CO2 to be added. Read this carefully. Calculate the mass of mixture to be removed, and the mass mixture will be removed and carbon dioxide will be added to give the required mixture at the same temperature. Required mixture means 70% carbon dioxide and 30% nitrogen by volume, and temperature and pressure will be constant in this. So in given data, we will use given data from problem 6.4. So in 6.4, volume is given to us is 3 cubic meter, contain a mixture of nitrogen and carbon dioxide. The analysis volume should equal quantity of each. Equal mean 50% nitrogen and 50% carbon dioxide. Volume fraction of CO2, volume fraction of CO2 initially in the start is equal to 50%. Equally mean 50%. It is equal to 50 divided by 100, which is equal to 0.5, and volume fraction of nitrogen initially 50%. Both are equal mean 50% nitrogen and 50% nitrogen and 50% carbon dioxide. Similarly, desired mean after we need this desired mixture. So in desired mixture, volume fraction of CO2 is equal to 70%, which is equal to 70 by 100, which is equal to 0.7, and volume fraction of nitrogen is equal to 30%. 30% mean 30 divided by 100, which is equal to 0.3. Similarly, from the problem 6.4, temperature and pressure are given to us. Temperature is equal to 15 degrees centigrade, which is equal to 15 plus 273 Kelvin, which is equal to 288 Kelvin, and pressure is equal to 3.5 bar, and 3.5 bar is equal to 3.5 multiplied by 10 power 5 Pascal, and Pascal is also equal to Newton per square meter. Similarly, molar mass of CO2 is equal to 44 kilogram. This is constant value. And molar mass of nitrogen is equal to 28 kilogram per kilomole. Required is find mass of CO2 added. Mass of CO2 added. and mass of mixture removed, not nitrogen, mass of mixture removed, mass of mixture removed, and this is given in this statement. Now we start solution. In solution, we know that initially initially volume fraction volume fraction and volume fraction is equal 50% and 50%, and we know that volume fraction is equal to mole fraction. Initially volume fraction of CO₂ is equal to volume fraction of N2, and we know that as volume fraction is equal to mole fraction, so mole fraction of nitrogen is equal to mole fraction of carbon dioxide, which is equal to n by 2. N by 2 means that in total is n, so in total 1 by 2 n is of nitrogen and 1 by 2 n of carbon dioxide. So first we find number of moles. N. So as we know that PV is equal to nRT, so N is equal to PV divided by R dash T. Pressure is given in problem 6.4, and we can use the data of problem 6.4. 3.5 multiplied by 5 Pascal or Newton per square meter. Volume is given in problem 6.4, 3 cubic meter. The R is constant, which is equal to 8.314 kilojoule per kilogram per Kelvin. So kilo and joule is equal to Newton meter per kilogram per Kelvin, and temperature is given as 288 Kelvin. So Kelvin will be cancelled with Kelvin. Newton is cancelled with Newton. This meter and meter square is meter cube. It will be cancelled with cubic meter. This is not correct unit. Sorry, this is kilonewton meter per kilomole per Kelvin. So Kelvin is cancelled with Kelvin. This Newton is cancelled with Newton. Meter and meter square is meter cube is cancelled with meter cube. So n is equal to, simplify this value, which is equal to 438.51, and this kilo is cancelled with kilo. So this mole is in double division, 4.51 mole. This is number of mole. Now we are calculating number of mole of nitrogen and number of mole of. So let we suppose, let X be the mole. This is mole, not mass. Noted that this is mole. Let X be the mole of mixture to be removed, and let Y be the mole of carbon dioxide. This is carbon dioxide to be added. This is X and this is Y to be added. Now we have to find X and Y, and X and Y are number of moles. So we know that number is number of moles of nitrogen is equal to, finally, n by 2. N by 2 is total number of mole of nitrogen before the process. Now after the process, this is 0.5x, half x, 0.5x, or we can write this as x by 2. 0.5x or 0.5 is also equal to 1 over 2. So this is x by 2. If we remove from total, it means then initially 50% nitrogen and 50% carbon dioxide. So if number of mole is n, so it means that n by 2 nitrogen and n by 2 carbon dioxide. So this is n, this is total nitrogen, and we will remove 0.5x. 0.5 1 by 2x mean there is total mole to be removed is x, as x be the mole of mixture. So total x by 2 of nitrogen will be removed, only nitrogen, because total mole of the mixture is x and there is nitrogen and carbon dioxide. So nitrogen to be removed from the mixture is x by 2. So this is n by 2 minus x by 2. And if when we remove this amount of nitrogen, these mole of nitrogen, the remaining mole will be 0.3 n. 0.3 n is due to because after the removal of the mixture and adding of carbon dioxide, nitrogen will be 30% and carbon dioxide will be 70%. So after the removal of this mole, these moles or this amount, the remaining will be 30%. 30% of nitrogen. So 30% mean 0.3 n. Now we can simplify this equation. So n by 2 minus 0.3 n is equal to x divided by 2. So now this is basically n by 2 means 0. This is basically 0.5 n. N by 2 1 by 2 means 0.5. 0.5 n minus 0.3 n is equal to 0.2 n is equal to x by 2. Now cross multiply this, so x is equal to 0.2 multiplied by 2. So x is equal to, and this is 0.2 n, so this is equal to 0.4 n. So x is equal to number of mole to be removed from the mixture are equal to 0.4 n. Now we are finding number of mole of carbon dioxide to be added to the mixture. Now number of mole of carbon dioxide to be added. Now number of moles of CO2 to be added are, so the total number of mole is equal to 1 by 2n minus 1 by 2x. This 1 by 2n minus 1 by 2x, this is, and we will add with this, we will add carbon dioxide with this. After the addition of carbon dioxide, after the addition, y is the number of mole of carbon dioxide. So y is the number of mole. After the addition of this, it will be 70% n. 70% n. This is 70% of the total. So 70% means 0.7 n. Now simplify this for y. So 1 by 2 n minus 1 by 2, and this is x. X is equal to 0.4 n. 0.4 n plus y is equal to 0.7 n. So this will be equal to 1 by 2 n minus 1 by 2 into 0.4 is equal to 0.2 n plus y is equal to 0.7 n. Now this will be equal to 1 by 2 n is equal to 0.5 n, and this is equal to minus 0.2 n plus y is equal to 0.7 n, or y is equal to 0.7 n this will be negative on this side and this will be positive on the other side, plus 0.2 n minus 0.5 n. So y is equal to 0.7 plus 0.2 is 0.9, and 0.9 minus 0.5 is 0.4 n. So x is equal to y is equal to 0.4 n, and we can find this because n is known to us. Number of mole, x is number of mole to be removed, and y is number of mole of carbon dioxide to be added. Now we can easily find this. X is equal to y is equal to 0.4, and n is basically 438.51 mole. 438.51 moles. So x is equal to y is equal to 175. Multiply these two values, 175.416 moles. Now convert this into kilomoles to divide by 1000. X is equal to y is equal to 175.416 divided by 1000 and multiply by 1000. Multiply by 1000 is equal to kilo. So x is equal to y is equal to 0.175416 kilomoles. These are number of moles. Now we are finding molar mass. So molar mass is equal to volume fraction of nitrogen. We can write volume fraction as Vn2 divided by total volume. This is volume fraction of nitrogen. Multiply by molar mass of nitrogen plus volume fraction of oxygen. This is basically volume fraction carbon dioxide. Multiply by molar mass of carbon dioxide. So molar mass volume fraction initially is 0.5, multiply by molar mass is 28 kilogram per kilomole, plus volume fraction of carbon dioxide is equal to 0.5, multiply by this is 44 kilogram per kilomole. So molar mass will be equal to, this is 0.5 multiplied by 28 is 14 kilogram per kilomole, plus 0.5 multiplied by 44 is 22 kilogram per kilomole. So molar mass will be equal to 14 plus 22 is 36 kilogram per kilomole. Now we can easily find mass of the, if number of moles are given to us and molar mass is given, then we can find mass, because we know that as number of mole is equal to mass in gram divided by molar mass divided by molar mass. Now mass is equal to n multiplied by molar mass. So mass, first we find mass of the mixture. Mass of the mixture to be removed. Mass of the mixture to be removed is equal to number of moles multiplied by molar mass. So number of moles are same in both cases for x and y. N is basically x. N is basically number of mole, and number of mole is basically x. Number of moles to be removed, and these are already determined by us, which are equal to 0.175 0.175416 0.175 kilogram per kilomole. Sorry, this is number of mole, multiply by molar mass for the mixture, not for nitrogen, for the whole mixture, for the mixture to be removed. So this is equal to 36 kilogram per kilomole. 36 kilogram per kilomole. So kilomole will be cancelled with kilomole, and final answer will be N. So mass of mixture removed is equal to 0.175416 multiplied by 36 is equal to 6.31 kilogram. And now mass of carbon dioxide CO2 to be added is equal to number of mole are same. This is y. This is here n is equal to y, and y is equal to 0.175416 kilomole. And number of mole of carbon dioxide, so molar mass of carbon dioxide is, this is molar mass, and molar mass of carbon dioxide is 44 kilogram per kilomole. So this kilomole will be cancelled with kilomole. So mass of carbon dioxide to be added is equal to 7.718 kilogram. If we round it, approximate, so this will be equal to 7.72 kilogram. So these are the final answer. Mass of mixture to be removed is 6.31 kilogram, and mass of carbon dioxide to be added are 7.718 or 7.72 kilogram. So this is the end of the problem. And for more problems, please like and subscribe my YouTube channel and share with your friends. Thank you.